Él nos va a platicar un poquito acerca de REST, Oauth y más, comprendiendo los estándares de facto de la nube para construir aplicaciones integradas. Como ven en la pantalla, bueno ya no, pero como estaba en la pantalla, la biografía de Ikai, él es ingeniero de desarrollo de programas en el motor de Google App. Antes de Google trabajó como ingeniero programador construyendo aplicaciones para móviles y redes sociales en LinkedIn. Ikai es un ávido de la tecnología y consume grandes cantidades de material acerca de nuevos lenguajes de programación, estructuras o servicios. Él vive en California y le gusta muchísimo vivir ahí y ganar concursos de karaoke chino y jugar fútbol. Los dejo con él, muchísimas gracias y nos vemos al ratito.
Buenas tardes. That's the only Spanish you'll hear from me this entire presentation. Just a warning, I was told that this video will be streamed, so unfortunately for everybody, I will be on my best behavior. Okay? So my name is Ikai LAN. First off, I want to tell you I work out of San Francisco, California, and I work for the developer relations team. How many people here in my talk this morning? Oh, okay. So just to warn you, I'm going to reuse a lot of the same jokes. So please go ahead and laugh along with them so it seems like I'm still funny. My focus in San Francisco is to work on App Engine and cloud technologies. If you want to follow me on Twitter or Google+, these are my addresses that you use. I will post these slides and the slides to all of my talks on these addresses. So follow me here. Now, before I begin, I like to make a little joke about what people did with my profile. So the first thing is, I don't know why they didn't use this picture of me. This was taken by a professional photographer. The picture that's on the website, I didn't brush my teeth, I didn't comb my hair, I didn't shave. But what's really funny about this profile is this last line. So I'm going to have you just read this last line to yourself and tell me if that translates well in Spanish. I think it translates very poorly, and that's, there's some things that you still can't have machines do. You still need people, which is why you're here. You know, we still need developers. We still need developers to write code and to do things that computers can't themselves do. So some preparation for this talk. I mentioned this morning that this talk was going to be much more beginner level. It's going to be much more high level. You'll be looking at these concepts from 10,000 feet. This talk is mostly language independent. I only have code on 1 or 2 slides, and it's just to make a point. So the agenda for today is we're going to go over 3 standards that people are using now to build web APIs and to talk to each other. And these standards are REST, JSON, and OAuth. We're going to give you a quick introduction to what these are, why I believe these standards have come to win out, and just some basics on how they work out. So before we get started, I'm curious, who here already knows what REST is? Who here knows what JSON is? And who here knows about OAuth? Okay, so we've got a good mix here. So I think I might have seen a few of you raise your hand 3 times. So I have to ask you, why are you here? Do you just like me? You're just, all right, well, we'll go through this. I believe that these are the tools of a trade nowadays. Anytime you're building any kind of API, you're building something that you want to integrate with different APIs, you have to have some understanding of these 3 topics. So the first topic we talk about is REST. And this is a picture I took when I was in Japan of the train system. And it was mostly because I didn't want to go online and pay for photographs. So I always try to look through my own photographs first to see if there's something that makes sense. REST is the transport mechanism for most APIs. But it's really just HTTP. You open a socket on port 80 or a secure socket on port 443. You send requests, and that's REST. You know, REST is mostly REST consists of usually a verb and a URI, which is an action, we call this a verb and a resource. And these are some examples of REST requests. You have a verb, and that's get, post, put, and delete. You're probably very familiar with get and post. Put and delete are much, they're less frequently used. And you have a resource, and the resource is the URI. Now, if you contrast this to people that have worked with SOAP before, you have an individual URI for every single resource you want to act on. And unlike SOAP, you use different verbs. So usually, when you're building an API, you try to map it as closely as possible to these concepts, which are any URI that you access via GET, it's usually a data read. A post, you're creating a new object. A put, you're editing something new. And if you're delete, well, you're deleting an object. So a REST request, I've greatly simplified what this looks like at the socket layer. But again, if you've ever looked at HTTP at the socket layer, you've opened up telnet, www.google.com 80, this is what you would type in. You would type in first the verb and the resource, and this corresponds to what you want to do. You type in the URI, and this would be the same thing as pasting the path inside your browser window. Usually you add an accepts header, and this tells the server, this is the type of response I can take back. And in this case, we're going to accept back JSON. And usually with post, put, and delete, you have some kind of payload. You have something in the body. And this is just a CGI escaped pair of values, right? You have something equals something, and so on and so forth. And it's very simple. It's just straight HTTP. So why is it a big deal? It's a big deal because until people introduced this standard, everyone was doing something different with APIs. It was just a complete mess. And you had to learn a new UI structure for every single API that you wanted to learn. And now that there's this kind of pseudo standard out there, you don't have to. You know that you can build against the Twitter API, and that you construct a resource UI and it'll work. You know you can build a Facebook app, and it's the same thing. On the server side, people like implementing REST because URIs map very well in most web frameworks to action. So let me do a quick poll of who uses frameworks here. So who here likes to use the Django framework? Anyone here do Ruby on Rails? Let me think. Spring. So how do you map a URI to, URIs almost always map to a method. The method is easy to test, it's easy to maintain. And that's part of the reason why I think that REST has become very, very popular, because you don't have to think as much when you're designing APIs. You just follow this formula, and you can create APIs that people understand, and you can easy to publish. So once you have your transport mechanism, you need to think about a data protocol. And JSON has recently come up as a protocol of choice when you're doing server-to-server API communications. So when you look at this, does this look familiar? It should, because this is just a JavaScript object. The way JSON came about was a little bit of a happy accident. So people started using JSON because in JavaScript you can call eval on it, and it becomes a JavaScript object. And people were using it in AJAX requests so they can send data back from a server in a way that the JavaScript didn't have to do any magic to parse. But as an accident, people started to realize that JSON is a really good format for sending data from an API to a different API. And why is that? Well, let's talk about the reigning champion, XML. Let's have them fight it out. Why did JSON win over XML? Well, I feel like JSON hasn't completely won over XML. XML is structured, and XML provides validation. So this is really nice for the Android programmers out there, because your configuration files, when you're editing them in your IDE, like IntelliJ or Eclipse, you say, oh, OK, I typed something wrong. Your IDE immediately knows if you're doing something wrong. I very rarely see JSON using configuration files. But JSON is very easy to generate using code, and it's really easy to parse using code. Every single language has some kind of JSON parser that will automatically map a JSON object to a dictionary or a hash. And here's the Python example I like to bring up. In Python 2.6 and above, JSON comes in the standard library. So when you have a dictionary object, you can dump it to JSON with a single function call. And when you receive a JSON object, you can turn it back into a Python dictionary with the opposite function call. It doesn't get any easier than this. I mean, how many people here have written a sax parser in XML before? I have. What about a DOM parser? How many people here liked writing that DOM parser? I thought I saw a hand here somewhere. No? Chris? I'm just picking on Chris. It's hard to write, but JSON is easy to write, it's easy to read, and it's easy to maintain. And that's why JSON has really supplanted XML as the protocol of choice when you're doing server-to-server communications. In fact, just about every modern web API uses JSON. Most of these APIs will also have an XML component, but a lot of them will only have a JSON component. So once we've got a transform protocol, that's already 2 ingredients to building and using web APIs. Hopefully I'm not going too fast. If I ever am, please let me know. We need one last thing, and this is the thing that's a little bit, it's the hardest to explain, and it's both authentication. And authentication is, is this person who he says he is? Is this Ikai LAN? Check his license, check his passport. And authorization. Okay, I know who he is, but should he be going into the bank vault? I don't know about that. There's a standard that's emerged called OAuth. And OAuth is known as the guest key for the internet. So I'd like to tell a story about the OAuth principle. When I was young, there was a neighborhood grocery store. And my mother would send me down with a list of groceries, and on that list of groceries, it would have a list of things she needed me to buy. She'd say, buy some milk or buy some cereal. But she wouldn't give me money because she didn't trust me with money. She knew I was going to buy candy. So I would take this list down to the grocery store, and this guy would look at it, and he saw that it was signed by my mom. So I'd take the things and I'd bring them back upstairs. So my mom's not giving me money, not directly, but she's giving me third-party authorization to speak on her behalf. That's what OAuth does. We have various Google APIs, and each one of these uses OAuth to authenticate. So I'm going to go into an example of how they use OAuth to authenticate. Now, of course, when you want to access someone's Google Calendar, you can always just ask for their password, log in as them, do some screen scraping. But this is bad. I mean, this is really, really bad. This would be the same thing as, when I'm 6 years old, my mother gives me a $100 bill. I'm not going to give my 6-year-old a $100 bill. I'm going to give him a math book. That's what I'm going to do. It's bad. You don't want to give out passwords because what you're doing is you're training users to give out their passwords to third-party sites. And this causes people to get hacked. This causes people to get phished. You want to train your users to be very smart about their passwords. Once you do this, it's also bad because a user can't revoke your access without changing their password. And once they do that, they've also revoked access to every other site that they've given their password to. It's insecure and it's not flexible. So here's our demo application. We're going to call it Sassy Payroll. Right? It's a software as a service payroll application. Now, this application is going to use OAuth to authenticate and do things on behalf of a user. So here's our fake application. You get a paycheck, and I got paid $800. So now I want these pay dates on my Google Calendar. I want to be able to know when am I going to get my next paycheck because I want to know how much time I have left before I need to start finding new ways to find food again and to eat again, right? So I click that button. I click this Add Pay Dates to Google Calendar, and it takes me to an HTTPS google.com page. I look in my browser, and I see a lock at the top of my screen. So sorry, there's a translator, and she's supposed to wave to me if I'm ever talking too fast. It looks like she's just fanning herself off. It's really warm in here. All right, just give me a thumbs up. So you're at this google.com page, and you see the lock, which tells you you're giving your password to Google. You're not giving it to ikaishadysite.com. You're not giving it to passwordsteal.com. You're giving it to google.com. You say, OK, do you want to let Sassy Passroll access your Google data? And you say, yes, give them access. So you do. And now this application can add items to your calendar, delete items, and edit items. To do this, the full steps, these are referred to as the OAuth dance. A user visits Sassy Payroll, and that's where you pull up the site in your browser. And Sassy Payroll makes a backend call to Google to get a request token. So Sassy Payroll goes to Google and says, this guy wants to authenticate. Can you give me a token? Google says, OK, we've worked with you before. That's cool. And this is automatic. Like, there are no people involved in this. This is all computers. So Sassy Payroll gets a token. And with this token, Sassy URL constructs a URL to forward the user to in their browser. So then Sassy Payroll just points the browser to this URL. It's a special google.com URL that says, once you finish these steps, we will forward you back to Sassy Payroll, and you'll have authorized granted. So the user is then forwarded to google.com, says, OK, allow access. And google.com says, cool. So google.com forwards the user back to Sassy Payroll. And on the back end, Sassy Payroll asks Google, because the user's back, did this user give me authentication? Google says, yes, they did. They do trust you. So Google gives them back an access token and a refresh token. And now, Sassy Payroll can use this access token to make API calls to GData and Google Calendar anytime the application wants, all without giving up a password. In addition, a user can change a password, and you're not going to have problems. A user can at any time later on go to a Google dashboard and say, I no longer want Sassy Payroll to add items to my calendar. And you can revoke access on an application per application basis. One more little detail is that sometime later, Sassy Payroll has to check in with Google every once in a while to get a new token. So you don't have a token forever. You'd like, give me back a new token. When you call an OAuth API, it's usually just HTTP. And most of the time, in this example, this is a REST-like example, right? You call a URL, and inside the header, you include all of the OAuth parameters that you need. OAuth parameters, these are OAuth 1.0 parameters. What you need to do is you need to pass a bunch of different parameters. You need to pass a timestamp. You need to pass a nonce. A nonce is a number that you only ever use once. You pass your own consumer key, not the secret. This is a key that you can trade. And of course, you sign everything. You sign things so other people can't pretend to be you. They can't just intercept the data and keep making calls to Google Calendar. It's all on top of standard HTTP, so you can build everything yourself if you have an HTTP client, and every single programming language in the world has an HTTP client. But you don't need to do this, fortunately, because every programming language in the world also has an OAuth client that will manage a lot of these little details for you. So our goals are met. We've built an integrated, robust application using OAuth that can directly manipulate a user's Google data, but we never, ever have to ask a user for their password. We never have to save a user's password. It's totally secure, and if, for instance, your database gets compromised, you can simply just rewrite your key, get a brand new key, and you're back at it, and the user doesn't lose any really important data. So hopefully it's a very short talk. I just wanted to give everyone here the building blocks to building and understanding web APIs. Almost every single web API nowadays uses these standard 3 technologies, right? I don't think I can name a web API that doesn't use these things. The first is REST. This is our transport layer. It's on top of HTTP. Every single client can speak it. You usually never have firewall issues. I don't know any corporate firewalls that completely block port 80 outbound. You could do a lot of things. You have JSON, which is a language that's very easy to parse, it's very easy to manipulate, and it's easy to use. And when you need to authenticate, you have OAuth. OAuth is, again, it's a valet key for an internet, but I recently realized that not every country has valets, so that's why I like to use the example of the shopping bag. And there are some key terms that you should learn, but for now, you have everything you need to start understanding these documents and understanding what each of these pieces do. A lot of people, when they first start doing OAuth, they say, why do I have to do this dance? And hopefully, you have some idea why. And it's a recipe for great applications. So I wanted to open things up to any questions that anyone here may have about any of these technologies or any of these APIs.
Hi.
Hi.
I wonder what about the. You have talked about the OAuth dance when you are through a web client. What about certain apps which have no an app client and still use OAuth 2.0, and the other ones that uses user credential to access to the token directly?
So this is, to me, this is still an area of contention, right? So a lot of what Android and iPhone applications do is they still do the OAuth dance, right? You still log in and you get forwarded to a site and you have to say allow or not allow this site. And then you get sent back to your native application and you authorize or you don't authorize. And I also see desktop applications. They open up a tiny web view and they say log into Google, yes or no. The problem with all of these approaches is that you can fake out a web view. I mean, if you're not in a browser, you don't get the lock that says you have securely connected google.com and not some site pretending to be google.com. So I think that there's still a lot of questions to be resolved, but I know that that's how a lot of mobile applications are solving this problem. So what Google does is, in Google accounts, if you want to log in with your phone and you turn on two-factor authentication, Google lets you generate one-time use passwords. So you generate a one-time use password, you enter it into your phone, and then you can log in. And that way, it's the same thing as an OAuth token where you can revoke it. Now, it's also challenging because it's not the easiest thing to use, but it's the only truly secure thing that you can do. So. It's a little bit, hold on now. Getting a little ahead of ourselves, aren't we? Well, that's okay. I'll be around all day, so if you have any other questions and you're too shy to ask in front of the live camera, you can come ask me in person. Okay? Thank you.
Thank you.